All right, so in number one, they're asking us to figure out which one of these intervals has the greatest average rate of change. Okay, so this is the formula we use when we want to find the average rate of change. So we have to go through each answer choice one at a time. So choice one says month 10 to month 60. Okay, so let's look at month 10, which is right here, and month 60, which is right here. All right, so now this first column, the M, is going to be our X1 and our X2. And the second column right here, the B's are going to be our Y1 and our Y2. So all we're going to do is we are just going to take these values right here and we're going to substitute them into our formula. So the formula says Y2 minus Y1 over X2 minus X1. So we're going to take Y2 and subtract Y1 from that, and we're going to put that over X2 minus X1. Okay, so there we have it. I just took Y2 minus Y1 and then did X2 minus X1. And we're just going to figure out what that's equal to, and when we do, we will see that it's equal to 28.398. Okay, so we're going to repeat the same exact process for each of the other three answer choices, and we're going to see which one has the greatest value. Okay, so here's choice 2, month 19 to month 69. So here's month 19, and here's month 69. So do the same thing. Y2 minus Y1 over X2 minus X1. Okay, right there. And when we do, we see that's equal to 32.76. So far, choice 2 is greater than choice 1, so choice 1 cannot be the answer. Okay, so here's choice 3, month 36 to month 72. Same thing, Y2 minus Y1 over X2 minus X1. And when we do, we see this one's even bigger. This one, we get 37.9169. Okay, so far this is the answer. I'm sorry, that's a 7 at the end, not a 9. And then finally, let's try choice 4. Okay, so we're using month 60 to month 73. So here's month 60 and here's month 73. So Y2 minus Y1 over X2 minus X1. And we could see this right here, 45.7. That is the biggest value, so that has the greatest, that interval has the greatest average rate of change. So choice 4 is the answer. All right, so number 2 wants us to find the completely factored form of this expression. Now, when you have 6 terms, you have to decide, am I going to group this into 2 groups of 3, or am I going to group it into 3 groups of 2? Now, a lot of times, if you just kind of look, you can kind of tell. Like, I could see that I'm probably going to group this into 3 groups of 2. And, I mean, the clue for me is this. There's a couple of them, but the main clue is, see how that's a 1 and that's a 9? If I pulled a 4 out of these, wouldn't I have a 1 and a 9? And if I pulled a 12 out of these, I'm not worried about signs, wouldn't I have a 1 and a 9? Okay, so that being said, I could see that I'm going to group this into 3 groups of 2. If you can't see that, no big deal, just try it out. If you try 2 groups of 3, you realize, oh, wait, I'm not getting the same thing in the parentheses, so this is not working for me. So then you just go back a race and try it the other way of grouping. Okay, so here, out of the first 2 terms, it looks like I could pull out an n squared. And when I do, that would leave me with, in parentheses, n squared minus 9. All right, now out of the next pair of terms, here I could pull out not just a 4, but a 4n. And please make sure you put the plus sign in front of it. Okay, and when I do, that's going to leave me with an n squared minus 9, which looks good so far, right? That matches up. Okay, and then out of these 2 terms, I'm going to not pull out a 12, but a negative 12. See how that's starting with a negative? Let's pull out a negative 12. And then when I do, that'll leave me with n squared. And then positive 108 divided by negative 12 is negative 9. So again, we'll have n squared minus 9. Now we know we're on the right track because these match up. So what we're going to do is we're going to take the terms in front of our common parentheses and we're going to group that together as our first factor. Okay, so I'm going to take the n squared the plus 4n and the minus 12, and there is my first parenthesis. And then we're going to take this common binomial, the common parenthesis, and write that once and once only. Okay, now you want to look at what you have and say, well, can I factor further? So here, if we can come up with two numbers that add to 4, that's a messy 4, but that is a 4, and multiply to negative 12, then this will factor further. And we can, right? If we do positive 6 and negative 2, don't they add to 4 and multiply to negative 12? Okay, so we're going to have n plus 6 and then n minus 2. Okay, and this, I think you guys all are really good with. This is just dots. It's a difference of perfect squares. So that's going to factor 2, n plus 3, and n minus 3. All right, so if we look through, it looks like choice 2, although they have it in a different order, right? They have the n plus 3 and the n minus 3 first, and then the n plus 6 and then minus 2 second. But multiplication is commutative. It does not matter what order you write them in, you will get the same answer. So choice 2 is our answer. Okay, now I want to point out, number 3 is different than number 2 because number 2, it's an expression and we're factoring it and stopping. Here, they want us to determine the zeros. So when they want us to determine the zeros, we're going to take this and set it equal to 0. And then basically we're going to have, at the end we make a t-chart and we solve. Okay, so there we go. I just took this and set it equal to 0 because they want the zeros. All right, so let's factor. Now, if you look at this, right, your first term in factoring is, can I factor out a greatest common factor? Okay, in number 2, we couldn't, right? There was nothing that we could take out of every single term, but look at this. Don't they all have an x? So let's first pull out an x. And that's going to leave me with x cubed minus 4x squared. Basically, all my exponents are just going down by 1. So minus 9x, and then plus 36. And then close the parentheses and equals 0. So now, since we have 4 terms in here, we're going to do grouping. So after I bring down this x, I'm going to group together the first 2 terms and group together the last 2. Now, out of these first 2 terms, we could pull out an x squared, which would leave me with x minus 4. And by the way, if you don't like to have parentheses within parentheses, you could always, let me just erase this for a minute. You could always make this, if you prefer, a bracket like that, and that way you don't have parentheses within parentheses, okay? So if that's more visually appealing for you, you could do that. All right, now out of the next 2 terms, I'm going to factor out a 9. But see how this is a negative? That tells me you always want to factor whatever the leading coefficient is. I'm going to factor out a negative 9. And then when I do, that's going to leave me with x and then minus 4, right? Because a positive divided by a negative is a negative. So it's going to leave me with x minus 4, which is great because these match up. Now, since I opened with a bracket instead of a parenthesis, I'm just going to close with a bracket. If you had kept the parenthesis, then you could close that parenthesis. All right, so it leaves me with x. Now, I'm going to group together this x squared minus 9, and I'm going to put that in a parenthesis. And then I'm going to bring down my x minus 4. And my equals 0. Now, you don't have to if you're solving, but I like to factor completely. So if you look in here, you could see this is dots, so we could factor further. But if you did make a t-chart at this point, you would still get the same answer. All right, so I'm going to factor that to x plus 3 times x minus 3. I'm just bringing everything else down. And because this is an equation that we're solving, we want to basically make a t-chart. You don't have to physically draw the t-chart if you don't want. You could just write out the answers. So here we get x equals 0, x equals negative 3, x equals positive 3, and x equals positive 4. So it looks like we have that right here in choice 1. And if you did want to check this graphically, because we have all real solutions, what you could do is you could go to y equals in your calculator and plug this in, and you could look and see, does the graph intersect the x-axis? Are these the zeros? Are these the points where the graph intersects the x-axis? And they are. Okay, so that's just a way to check. All right, so number 4, they give us a 3x3 system, right? 3 variables and 3 equations. And when it is multiple choice, I do not recommend you doing this by hand. For a show your work question, definitely do it by hand. But for a multiple choice, I want you to just do it using a matrix in the calculator. Okay, so what we're gonna do is in the calculator, we're gonna hit second, and then see what says matrix right there. Okay, we're gonna go over to edit and hit enter. Now mine already says 3x4, which is what we want because we have 3 rows and 4 columns, right? 1 for the x's, 1 for the y's, 1 for the z's, and 1 for the numbers. So I'm just gonna hit enter to go right past that. Actually, this matrix is in my calculator already. Look at this. The numbers we were typing is 1, 2, -1, and 1. I'm gonna do it anyway, just so I could show you, but I'm gonna hit 1, enter, 2, enter, -1, enter, and then 1, enter. Then I go to the next row and I type in -1, -3, 2, 0. So -1, -3, 2, and 0. Okay, and then the last row is going to say 2, -4, 1, 10. So 2, -4, 1, and 10. And you really do want to check and make sure all your values are right, because even if you have one value off, it's not going to work out for you. Okay, so now we want to quit this screen, right? So you're going to quit second mode. That's how we quit. Now we're going to go back to a matrix for the second time. So second and then matrix. And you're going to go over to math and scroll up to RREF, which is letter B, and hit enter. Then we go to a matrix for our third and final time. So again, second matrix. And you're going to hit enter saying this is the one we want to use. And when you hit enter again, you'll see these are our answers: -3, -1, and 0. Okay, let me move this over. So -3, oh, look right here. Oh, I'm sorry, not -3, +3, -1, and 0. So +3, -1, and 0. So choice 2 is our answer. All right, number 5. So they want to know which expression is equivalent to this. Now, the first thing I want to do is I want to get these out of radical form. So if you remember, if we use the rule power over root, I could rewrite this as x to the 2/3 power. Okay, now same thing here, right? This I could write as x to the 5. Now there's no root in here, but we know we say the square root. So there's actually technically a little 2 right there. So we could write this as x to the 5/2 power. Okay, and then on the bottom here it says, really there's no exponent, but we know that's x to the 1st. So this would be x to the 1/6 power. Okay, so now from here it's kind of just smooth sailing. We know that if we're multiplying 2 terms with the same base, we add the exponents. Okay, so you can add 2/3 plus 5/2. Okay, so let me actually show the work over here to the side. So I'm adding 2/3 plus 5/2. I'm finding a common denominator of 6. So I multiplied this by 2/2 and this by 3/3. So that gives me 4/6 plus 15/6, which gives us 19/6. So I could rewrite this numerator as x to the 19/6. And then that's going to be over x to the 1/6. Now, whenever we're dividing 2 terms with the same base, don't we just subtract these exponents? So they already have a common denominator, so that should be fairly easy, right? 19/6 minus 1/6. Well, 19 minus 1 is 18. So that would give us 18/6. And then doesn't 18/6 just simplify to 3, right? So when we subtract them, we get 18/6, which is just 3. So this is going to just leave us with x to the 3rd, which is choice 3. Okay, so number 6, I mean, this you can go about a couple different ways. And by the way, this isn't a to the 3rd. This is the cube root. Okay, same thing here, cube root. So you could individually try to take these out of the cube root, but I'm looking ahead. Like the cube root of 2 is not a perfect cube, and the cube root of 4 is not a perfect cube. So what we could do instead is we could multiply together what's under these cube roots, And the only reason I say that is because isn't 2 times 4 8, and isn't 8 a perfect cube? Okay, so I'm going to go about it that way. You don't have to go about it that way. You could individually take these out of the cube roots, but I'm going to first take this a, that's right there, and just bring it down. And then I'm just going to make 1 cube root. And we know that 2 times 4 is 8. Okay, this has an a squared. That doesn't have any a, so I'm just going to leave the a squared alone. And then b squared times b is b to the 3rd power. Okay, so now I'm going to try to get all this out of the radical. Now again, the cube root of 8, it just means what can I multiply by itself 3 times to give me 8? Well, 2, right? 2 times 2 times 2 is 8. So the cube root of 8 is just a 2. So I'm just going to take a 2, and I'm going to put it on the outside in front of the a, because usually our number comes first, right? Now, if we use power over root, wouldn't that be a to the 2/3 power? Put a little multiplication dot, a to the 2/3 power. And then if we did b to the power over root, we'd have b to the 3/3. But isn't 3/3 just 1? So it's just going to be b to the 1st power. Okay, now, if I look here, I could do, there's a couple different things I could do, but I'm looking ahead at my answer choices. It looks like here I have a 2, an a, and a b, which up here I see I have a 2, an a, and a b. And then, doesn't this say a to the 2/3 power? Doesn't this mean a to the 2/3 power, right? If we do power over root, wouldn't that be a to the 2/3 power, which is what this says? Okay, so this matches up with this. So we really don't have to do anything. I mean, choice 1 is the answer because all of our terms match up with all of the terms up here. So I know a lot of times you could say, oh, here, look, we have 2 terms with the same base. Let's add the exponents. We don't even have to, okay? We could stop at this point because we can recognize that choice 1 is our answer. All right, let's take a look at number 7. So they want to know which of the following is equivalent to this original expression. All right, I'm going to first start off, I think, by just distributing the 6xi cubed within the parentheses. Okay, so that would leave me with negative 24. And then x times x is x squared. And then I cubed times I would be I to the 4th. Okay, and then plus 30, and then xi cubed. All right, now let's think about this, okay? So we don't ever want to leave ourselves with exponents on i's. So I to the 4th isn't, I'll do this off to the side, isn't I to the 4th just I squared times I squared? And we know that I squared is equal to negative 1. So isn't negative 1 times negative 1 just positive 1? So this I to the 4th right here is just equal to positive 1. Okay, so we have negative 24x squared times 1, which is just negative 24x squared. And by the way, if you wanted to double check, you could plug I to the 4th in your calculator and it'll let you know it's equal to 1. Okay, now let's think about I cubed. Isn't I cubed just equal to I squared times I? And we know I squared is equal to negative 1. And I is just I, you can't do anything with it. So negative 1 times I is negative I. So that leaves us with 30x times negative 1, times negative I. And I mean, basically, wouldn't this just leave us with a positive times a negative is a negative? So wouldn't that just leave us with negative 30 and then xi? All right, so if we look right here, choice 2 is our answer. That matches up. Okay, number 8, they want to know what is the solution to this equation. So I rewrote it over here. Now, because we're solving for an exponent, we want to get the base that contains the exponent on it all by itself on one side of the equation. So we want to get rid of this 8. So let's just take both sides of the equation and divide it by 8. And that will leave us with 2 to the x plus 3 power equals 6. Okay, now, whenever we're solving for an exponent, we know we're going to have to use logs. So I'm going to put the word log in front of both sides of the equation. And the reason we do that is because we know the power rule tells us that we could take this exponent and bring it to the front of the word log. Okay, so I took the x plus 3 and brought it in front of the log of 2, and then I brought everything else down. All right, so we want to get this x by itself, and it's within the parentheses with a plus 3. So let's first get rid of the log of 2. Let's divide both sides of the equation by log of 2. Now, normally what I would do at this point is I would, in my calculator, I would plug in log of 6 divided by log of 2, and I would round it to at least 4 decimal places on my paper. But I'm actually going to leave it like this for right now because I'm kind of looking ahead at the answer choices. So I'll explain that in a minute. But let me, on the left side of the equation, cross off the log of 2's and bring down the x plus 3. So the parentheses are no longer needed, right? And again, I'm going to just leave this for right now as log of 6 divided by log of 2. Because we know to get the x by itself, we're going to subtract 3 from both sides, which I'm going to just put it here because, again, I'm looking ahead at the answer choices, which leaves me with x, here I'll rewrite it, x equals log of 6 divided by log of 2 minus 3. Now, this is the only thing. When you look at the answer choices, I mean, choice 1 says the same thing, but they're using an ln instead of a log. And technically, you're really supposed to be using an ln when we're dealing with an e. But if you take log of a number divided by log of some other number, it's actually equivalent to taking ln of that number divided by ln of that same number that you used over here. I wish they had written the answer choice like this because technically this is what we're supposed to do to solve it. But even if you decided to put this in your calculator and figure out what it's equal to, okay, so I plugged this in my calculator, and here was the output value. And then I plugged choice 1 in my calculator, and here was the output value. So you could see they actually are equivalent to each other. So choice 1 is our answer. Okay, so number 9 can be a tricky question. Now, I'm going to try to go about it in the most direct way as possible. Now, if we want to know what is not a solution, let me actually highlight that word not because I want to make sure we're not picking what is a solution. I would first just take this equation right here and solve it. Now, because we're solving for an exponent, we know we're going to use logs. So let me I'll just do it off the side here. So I'm going to put the word log in front of both sides of the equation. And the reason we do that is because we know that the power rule tells us you could take an exponent, okay, which we have right here, and we could bring it in front of the word log. Okay, so that's what I did. I took this exponent and brought it to the front of the word log, and then I just brought everything else down. Now, if I want to get this t by itself, I'm just going to divide both sides of the equation by log of 2. So that leaves me with t equals 1.66. It says 096, so technically that would, the 09 would round to a 10. I'm going to just write 096. But if you wanted to, you could take this 6 and round this 9 up to a 10. Okay, but either way, I would just plug each answer choice in your calculator one by one and see which one is also equivalent to the same decimal. Okay, so I plugged in choice 1. Oh, sorry about that. I plugged in choice 1 into the calculator and got the same decimal. Choice 2 gave me the same answer. Choice 3 gave me the same answer. And look, choice 4 is the only one that did not. This does not match up with that. So choice 4 is the answer. This is the one that is not a solution. Okay, number 10, they want us to solve the given equation. Now, because this is a fraction, I would just take everything and make it into a fraction by putting it over 1. Okay, I rewrote it over here just to give myself a little more room. Now, the reason we make everything into a fraction is so we can find a common denominator. Now, this denominator says x minus 1, so we could easily get these to say x minus 1 by just literally putting it there, right? Okay, so I'm going to put an x minus 1 on the bottom here, but whatever you do on the bottom, remember you also have to do on the top, so put it up there too. And then same thing over here. I'm going to put an x minus 1 in the denominator, and I'm allowed to do that as long as I also put it in the numerator. And now, since all these denominators say exactly the same thing, we can just cross them right off. Okay, so I just rewrote exactly what I saw up here, right, in the numerators, and this is what we're going to solve. Okay, so let's double distribute. So x times x is x squared. X times 3 is 3x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. I'll bring down the minus 4. And then equals 5x minus 5. Now I know I need to combine my like terms, and I also know I need to get one side of the equation set equal to 0. So I'm going to do that all at once. Let me subtract 5x from both sides. And I'm going to add 5. Okay, so on the right-hand side of the equation, that all cancels, giving me 0. And this x squared does not combine with anything, so I'm just going to bring it down. And if I combine 3x minus x and minus 5x, wouldn't that be negative 3x? And then if I combine negative 3, negative 4, and positive 5, that's going to be negative 2. Okay, so now, I mean, first of all, I could tell right off the bat I'm not going to be able to factor this just based on my answer choices, right? We wouldn't have radicals in our answer choices if we could factor. So I'm just going to jump right into using the quadratic formula. All right, so I'm going to, let's see. So we'll write x equals, and just a reminder, my a is 1, my b is negative 3, and my c is negative 2. So x equals negative 3 would be positive 3, plus and minus the square root of b squared, I'm just plugging in the numbers as I say the formula, minus 4 times a, right, which we said is 1, times c, which is negative 2, over 2 times a, so 2 times 1. All right, so that leaves us with x equals 3 plus and minus the square root of 9, and then a negative times negative is a positive, so plus 8. 9 plus 8 is 17 over 2. Now, if I look at the answer choices, I could automatically eliminate choice 2 and choice 4, because they have i's, right? In order to have an I, we have to have a negative under the radical, which we don't. And then, I mean, look, it's got to be choice 1. There's radical 17. We don't have radical 33. So all they did was they just split it up into 3 over 2, plus and minus radical 17 over 2. Okay, so choice 1 is our answer. All right, number 11, consider the end behavior description below. So as x approaches negative infinity, right, that means as the x's are getting smaller, we are going to the left. So as we're going to the left, this says f of x is approaching infinity. So the y values are getting bigger, right? The y values are going up. So on the graph on the left, it should be an arrow going up. Okay, now this means as x approaches positive infinity, so as the x values are getting bigger and bigger. So the x values get bigger and bigger as we go to the right on our graph. So as we go to the right on our graph, the y values are approaching negative infinity, which means they're going down. So we're looking for a graph. Oop, that's supposed to be a W. That's a really funky W. We're looking for a graph that on the left, it goes up, and on the right, it's going to be pointing down. Okay, so what I did was I took a picture of, I graphed this in my calculator and put a picture of it here. And I graphed this in my calculator and put a picture of it here. Although we technically did not need our calculator, right? We know that if this is a 4th degree function, if it's an even degree function, it's going to be opening in the same direction. And because it has a positive leading coefficient, it's opening up. Here, we know that if it's an odd degree function, it's opening in opposite directions, right? And because the leading coefficient is negative, the right side should be heading down. But either way, we're looking for the left coming up, which we see right here, and the right going down, which we see right here. So choice 3 would be our answer. Okay, so number 12, they're looking for you to do long division here. Now, if you notice, the terms, the exponents go from x to the 4th down to x squared. It's missing that x cubed term. So what we do is when we put this under our division bar, we write plus 0x cubed. Okay, and what's in the denominator goes outside the division bar. That's what we're dividing by. Okay, so let's do long division. So we want to look and say, well, what do I multiply x by to give me x to the 4th? X cubed. So that's what's going to go up here. And then when I distribute, x cubed times x is x to the 4th. And then x cubed times 2 is 2x cubed. Okay, now we know we have to subtract. So in order to do that, we change our sign and circle it. And we change this also to subtraction and circle it. Okay, so then the first two terms, they're just going to cancel, right? And then 0x cubed minus 2x cubed would be negative 2x cubed. And I'm going to bring down my next term. And then we just start the process again. We do this until we're done, pretty much. We keep repeating the same process over and over again. So I'm going to look at the first term on the outside of the division bar and the first term of what I have down here. And I want to say, well, what do I multiply x by to give me negative 2x cubed? So negative 2x squared. And then I'm going to distribute that negative 2x squared to both terms outside the division bar. So negative 2x squared times x would be negative 2x cubed. And negative 2x squared times positive 2 will be negative 4x squared. Okay, and then I want to change my signs. Change this to addition and circle it. Change this to addition and circle it, just to show that I'm subtracting. Okay, so now these first two terms cancel out. And negative 5x squared plus 4x squared would be negative 1x squared. I'm just going to write negative x squared. And we bring down the 4x, the plus 4x. All right, so let's do the same thing again. So what do I multiply x by to give me negative x squared? So negative x. So negative x times x is negative x squared. And then negative x times 2 is negative 2x. And then we're going to change our sign. So this becomes addition and circle it. And this becomes addition and circle it. And our first two terms cancel. And 4x plus 2x would be 6x. And we're bringing our last term down. So this is the last time we're going to repeat this process. Okay, so what do we multiply x by to give us 6? To give us 6x? Just a 6. So let's put this at top, plus 6. And when we distribute, 6 times x is 6x. 6 times 2 is 12. And when we change our signs, it looks like we're going to wind up with a remainder, right? These cancel. But 14 minus 12 is 2, so that's our remainder. So what we do is up top, since it's positive, we write plus, and we take that 2, and we put it over what we're dividing by, which is x plus 2. All right, and it looks like that matches up with answer choice 1. Okay, so number 13 deals with half-life. It says a certain pain reliever is taken in 220 milligram dosages and has a half-life of 12 hours. All right, so we could see this here. Okay, this is the initial amount, and it has a half-life of 12 hours. So this is just our half-life formula. All right, according to this function, which statement is true? All right, so let's see. Every hour, the amount of pain reliever remaining is cut in half. Well, if the half-life is 12 hours, that means every 12 hours, the amount will be cut in half. So choice 1 is not true. Okay, choice 2. In 12 hours, there is no pain reliever remaining in the body. Well, that's not true either. In 12 hours, it means the amount of pain reliever is cut in half. So choice 2 is no good. All right, choice 3. In 24 hours, there is no pain reliever remaining in the body. Well, okay. After 12 hours, the amount is cut in half. So if you start with 220, half of that would be 110. But then if we go 24 hours, another 12 hours, that's going to be cut in half again. So half of 110 would be 55. So there'd really be 55 milligrams remaining, not none. Okay, so this one's not right either. So in 12 hours, 110 milligrams of pain reliever is remaining. Yeah, this is it. Right, if the half-life is 12 hours, that means that the amount you start with will be cut in half. So half of that is 110 in 12 hours. Okay, so choice 4 is the correct answer. All right, so number 14 also deals with half-life. So I just wrote out the half-life formula here. Now, this one is a little deceiving because when you look at the chart, like they don't ever tell us how much we originally started off with. It just says after one half-life, this is what remains. Now let's think about this. If this is what remains after one half-life, doesn't that mean there had to be twice as much as this, right? Double this before we ever had the half-life? So if you take this, I'm going to actually make my own little column here. Look at this. When we have 0 half-lives, right, that means we're going to have twice as much as before we cut it in half. So if you take this number, 139, and double it, actually I can't fit it. I'm going to put an arrow. That means initially we started off with 278. All right, so let's see if that makes sense. So initially we had 278. Then after one half-life, we cut that in half, and this is what we had. Okay, after 2 half-lives, we would cut this in half again, and that's what we had. But really, this is the number we're concerned with. This is the initial amount. So that's what's going to go in for P. Okay, then there's a 1/2 in our formula. T stands for the time that has passed, which is right here, 18 hours. And then H stands for the length of time a half-life is. So it says right here that the half-life is 1.8 hours. Okay, and we're solving for A. So all we have to do is literally just plug that in our calculator and see what we get. And when we do, we get 0.271. So choice 3 is our answer. Okay, so number 15, we're solving a fractional equation. I rewrote it because I like to give myself a little more room. But with a fractional equation, the first thing we want to do is we want to find a common denominator. Now, since these two denominators on the outside both say 3x plus 1, and the denominator of the fraction in the middle says x, we need to include all of that in our common denominator. So our common denominator is going to be x times 3x plus 1. So this first fraction and this last fraction both have the 3x plus 1. It's missing the x. So what I'm going to do is I'm going to put an x in the denominator on both fractions, but whatever you put in the denominator, don't we also have to put in the numerator? So I'm also going to put an x on the top of each fraction. Now this middle fraction had the x, but it was missing the 3x plus 1 that our other fractions have. So I'm going to put a 3x plus 1, on the bottom, and whatever we put on the bottom, we have to put on the top as well. Sorry, this pen is not doing the best for me right now. Okay, so anyway, now that they all have an x and a 3x plus 1, x and 3x plus 1, we could take those denominators and just cross them right off. And we are going to solve what we're left with up here in the numerators. All right, so let me rewrite this. Okay, so this is what we have. So then x times 2 is just 2x. So we have 2x equals, when you distribute a 1, it stays the same. So it's going to stay as 3x plus 1. And then negative 6x times x would be negative 6x squared. Now, I'm going to move everything to the left-hand side of the equation because my leading coefficient right now is a negative, and I don't like that. So I'm actually, even though it's more to move, I'm going to add 6x squared to both sides. Oop. Let's rewrite that one. I guess I'll kind of line it up over here. I'm going to subtract the 3x. And I'm going to subtract the 1. Okay, so basically on the right, these cancel, and these cancel. That's what we wanted to happen. On the left, I'm going to bring down the 6x squared. And then 2x minus 3x is negative x. And then this minus 1 doesn't combine with anything, so I'm just going to bring it down. right, so now all we have to do is just factor, make a t-chart, and solve. So we're going to be doing the rainbow, right, because of the number in front of the first term. If it's anything other than a 1, we know we're going to use the rainbow. So let me bring down my first term, bring down the last term, and we need to come up with two numbers that multiply, well, there's my rainbow, it's pretty big, but they multiply to -6 and can add to +1. So -3 and +2. So I'm going to put a -3 with an x and a +2 with an x. And then when we did grouping, out of the first two terms, I could factor out a 3x, which leaves me with 2x minus 1. And of the last two terms, the only thing I could take out is a +1, which also leaves me with 2x minus 1. Okay, so now I can group together my 3x plus 1 in my first parenthesis. And my second parenthesis, I'm going to rewrite that common binomial we see of 2x minus 1. Okay, so at this point, I think we're all good with the shortcut of how to solve, right? We get x equals the opposite of what's here, so -1 over what's in front of the x, so -1/3. Okay, and then over here we get x equals the opposite of what's here, so +1 over the number in front of the x, 2, so +1 over 2, +1/2. Now with these, it's really important to check for extraneous roots, because sometimes your answers will check and sometimes they won't. Okay, so let's start with this, -1/3. If we take -1/3 and plug it in for x into the denominator, well, 3 times -1/3 is -1. And -1 plus 1 is 0. We cannot have 0 in the denominator of a fraction. So this one I'm going to cross off because it's an extraneous root. I'm just going to write extraneous. Okay, if you take the 1/2 and substitute it in for x into any of these denominators, it does not create a 0. So we're allowed to have that. So the 1/2 does check. So choice 3 is the answer. And if you want to just store x as these values in your calculator and type in the left-hand side of the equation and then type in the right-hand side of the equation and see if they check, you definitely can do that. You would see that the -1/3 does not check, okay? It would say error, and that the +1/2 would check. Number 16, they give us f of x, and they want us to find the inverse. Okay, this little symbol means inverse 2 of the function. All right, now, if you remember, the inverse, we want to find the inverse of a function, we want to switch the x and y. Okay, now, we know that technically f of x is just a fancy way of saying y, so we're going to switch this to an x, and I'm going to bring down the equals -2/5, and we're going to switch this x to a y, and then bring down the +4. All right, now all we want to do is solve this for y. So in order to do so, let's first get rid of this 4 by subtracting it from both sides of the equation. So that'll leave us with x minus 4 equals -2/5 y. And then finally, we just have to get rid of the -2/5 in front of the y, so we're just going to multiply by the reciprocal of this. Now, the reciprocal just means to literally take the fraction and flip it upside down, and you're going to keep the sign that's there. So see how that's negative? We're going to multiply this side of the equation by -5/2. And we're going to have to do the same thing to the left side of the equation. Okay, so on the right side, the -2/5 and the -5/2 cancel. And I'm going to, at this point, change this y back into function notation, but instead of writing f of x, this is our inverse. We're going to write f inverse of x. And then let's just distribute. -5/2 times x would be -5/2 x. And then -5/2 times -4, well, a negative times a negative is a positive. And then if we think about this as, let's just say, 4/1, that would leave us with 20/2. And doesn't 20 divided by 2 just simplify to 10? Okay, I know some of you guys like to put this in the front, so I just rewrote it. So f inverse of x equals negative 5/2 x. I just brought this down, plus 10. Okay, so this is in what we call slope-intercept form, or y equals mx plus b. So the number in front of the x is your slope, so we have a slope of negative 5/2, and the number at the end represents your y-intercept. So if we go back to the question, they want to know which statement is true. So the first two say the slope is 5/2 or 2/5, which is not true, right? We just said the slope is negative 5/2. So these are both not true. All right, I'm going to jump over here to choice 4. It says it has a y-intercept of 0, negative 4. Well, here, this is our y-intercept. It actually has a y-intercept of 0, 10, not 0, negative 4. So that one's not true either. All right, and then if you take a look at choice 3, it says it passes through the point 6, negative 5. Okay, so if you go to y equals in your calculator and just type this in, okay, negative 5x plus 10, negative 5/2 x plus 10, and go to the table of values, look at this. We see that it does go through the coordinate 6, negative 5. All right, so choice 3 is our answer. Okay, so in number 17, they want to know which equation represents a parabola with this focus and this directrix. Now, this is the general format of a parabola that opens up. So, and if it opens down, we'll just throw a little negative in front of here. All right, so we have a focus at negative 2, 5. So let's plot that. So I'm going to go back 2 and up 1, 2, 3, 4, 5, and we're going to put a point right there. Okay, so that is our focus. I'm just going to label that F. All right, then it says we have a directrix at y equals 9. So y equals 9 is right up here, and it's just going to be a horizontal line. So that's our directrix. Okay, now, we know that, I'm just going to label these. We know that our vertex is midway between the focus and the directrix. So since there are 1, 2, 3, 4 units in between these, half of 4 would be 2. So if I go down 2 from the directrix, or if I go up 2 from the focus, I'm going to meet right in the middle at my vertex. Okay, so the coordinates of that would be negative 2, 7. Now, I could tell my parabola is going to open down because, remember, it always opens away from the directrix. It'll never open into the directrix, okay? So this is going to open down. So that being said, our formula that we have over here, we need to put a negative in front of that fraction. Okay, so let's see. We have y equals negative 1 over 4 times, well, P is just the distance from the directrix to the vertex, or from the vertex to the focus, which is 1, 2 units. So I'm going to plug in a 2 for that P. Okay, and then it's x minus, now h and k we get right here from the vertex. So h is negative 2. So if we have x minus negative 2, doesn't that become x plus 2 squared? And then our k is this positive 7, so plus 7. Okay, and just keep in mind, when you go to write an equation, whatever's in the parenthesis is going to have the opposite sign of the x-coordinate, and whatever's outside here is going to have the same sign as the y-coordinate. All right, so if I were to rewrite this as y equals negative 1/8 times x plus 2 squared 7, I don't see that as an answer choice. So I need to get this equation to look like one of these. Now, what you could see is in all of the answer choices, they have the term with the square on it all by itself. So here's our term with the square on it. I could actually automatically eliminate choices 1 and 2, only because these say y minus 7 squared, and we have an x plus 2 squared. So it's got to be one of these. And then honestly, out of process of elimination, see how that's a negative? And we have a negative. I'm assuming choice 4 is the answer, but let's just make sure it is. All right, so I want to get this x plus 2 squared by itself. So in order to do so, I'm going to first subtract 7 from both sides of the equation. So that leaves me with y minus 7 equals negative 1/8 times x plus 2 squared. And then to get this x plus 2 squared by itself, I'm going to multiply it by the reciprocal of negative 1/8. So negative 8 over 1, which is really just negative 8, right? So if I do that to the right side of the equation, I have to do that to the left. So I'm going to put this in parentheses, and I'm just going to throw a -8 right in front of it. Okay, so the -1/8 and the -8 cancel, so this leaves me with, I'm not going to distribute it, only because when you look at the answer choices, you could see they don't distribute the -8, right? They just leave it on the outside. And then I'll bring down my x plus 2 squared. So we could see that that does match up with choice 4. Okay, it's just in the opposite sides of the equal sign, but that doesn't matter. All right, so number 18, they want us to take this function right here, which is written in terms of years, and they want us to change it to quarterly growth rate. Okay, so quarterly growth rate means it's basically growing 4 times per year. So this number right here, what we're going to do is we're going to put in front of the t. Okay, because then on the outside of the parentheses, instead of this representing years, it's representing 4 times per year, which is just another way of saying each quarter. Now, if you put a 4 in there, it changes the value of our function. So to compensate for putting a 4 in there, we put its reciprocal, 1/4, on the inside of the parentheses. Okay, and then from here, all I'm going to do is I'm going to bring down the beginning of the function. This doesn't change at all. Okay, now, in your calculator, you're going to type in 1.045 to the 1/4 power. And you could see in the answer choices here, they rounded to the nearest thousandth. So let's do the same. So when I plug this in my calculator and round to the nearest thousandth, I get 1.011. And then if you look at the answer choices, they're not in terms, the exponents are not in terms of t, they're in terms of q for quarters. Now, didn't we say that this means 4 times per year? And 4 times per year is just another way of saying a quarter. So we can kind of replace this 4t with a q. And if we look at our answer choices, that matches up with choice number 1. Okay, number 19. So this time they give us this function c, t, and this d represents, it says decades, okay? It represents the number of decades since the study began. Now what they want us to do is they want us to calculate yearly growth rate. All right, so if we think about yearly growth rate, since we're talking about decades out here, doesn't a year happen 10 times per decade? Because if we want to switch from decades to years, that happens, years happen 10 times per decade. So this 10 is what we're going to put in front of the date. And then to compensate for that, right, because didn't that completely change the value of our function now by just putting a 10 there? So what we're going to do is we're going to put its reciprocal on the inside of the parentheses. You know, let me just hold on. This 10, I don't know what that looks like. I'm going to erase that for a minute. Let's write that again. So that's supposed to be a 10. There we go. Okay, so we're going to do the same thing we did for the last one. What we're going to do is we're going to bring down the beginning of our function. Okay, that doesn't change. But what we see in the parentheses here, we're going to plug this in our calculator. So we're going to plug in 1.849 to the 1/10th power. Okay, and when we do, it looks like, I'm just looking at the answer choice here, it looks like we're going to get 1.0634. But the answer choices are not in terms of D, are they? They're in terms of Y's. So let's think about this. 10 times per decade. Well, what happens 10 times per decade? Doesn't a year happen 10 times per decade? So this is the same thing as saying a year, and they want us to use Y for year. All right, so that matches up with choice 4. All right, so number 20. Which of the following is not a factor of this expression? Okay, just underline that word not to make it stand out. Now, I mean, if you have 4 terms, you could try to factor this through grouping, right? So if we were to group together the first 2 terms, here I could pull out an x squared, which would leave me with x plus 6. Okay, now out of the next 2 terms, other than, what, a -1, there's really nothing I can pull out, and that is not going to leave me with x plus 6 in parentheses, okay? It leaves me with 19x plus 84. So we could see that if we tried to do this through, algebraically, through grouping, right? These are not equal, so this is not going to work out for us. So how else can we do this? All right, well, don't we know that if we were to do this graphically, if we graphed this expression right here and looked at where the graph crosses the x-axis, right? Those are called our zeros or our roots or the solutions. Can't that help lead to our factors? Okay, so let's do it. So I took this function, the original right here, and I plugged it into my y equals, and I can hit graph. And if I look at where the graph crosses through the x-axis, it looks like it's going to cross right over here. Let's count back. Negative 1, 2, 3, 4, 5, 6, 7. So at x equals negative 7. So the factor that corresponds with that has the opposite sign, right? X plus 7. So choice 1 is not an answer. Right here at x equals negative 3 is another 0. So wouldn't the factor be x plus 3, which is what choice 2 says? And also over here at x equals positive 4. So the factor would have the opposite sign, x minus 4. So that's what choice 4 says. So choice 3 is your answer. I mean, you could also, if you want, you could hit second graph. And if you look in the table of values, we're looking for the y equals 0. So I'm going to keep scrolling. Okay, we can see right here at negative 7, the y value is 0. So negative 7 is a 0. So that would make x plus 7 a factor. Right? Factors always have opposite signs. See right here at negative 3, 0. Negative 3 is also a 0, so x plus 3 would be a factor. And then if I scroll down, let's see, I have another one right here, okay, at 4, 0. So if x equals 4 is a 0, then x minus 4 would be a factor. All right, number 21. So the graph of a cubic polynomial function, p of x, is shown below. So here we go. All right, I just want to point out, we could see that we have zeros at negative 2 and at positive 1. So that means we would have factors at x plus 2 and at x minus 1. Now it says here, if p of x is written as a product of linear factors, so they're talking about the factors here, which factor would appear twice? Okay, do you remember where the graph bounces off the x-axis like it's doing here? That's where we have multiplicity. This is the factor that's going to appear twice. So remember, the factor that corresponds with the 0 of x equals negative 2 is x plus 2. Okay, so we would have an x plus 2 squared. So the x plus 2 is the factor that appears twice. Okay, so moving right along. Number 22, factor the expression completely. Okay, so you first want to look and say, is there anything I could factor out of all 4 terms? And there's not. So if we have 4 terms, we know we're going to jump into grouping. So if I group together these first 2 terms, it looks like I could pull out just an x squared. Okay, and that's going to leave me with 5x minus 2. Okay, if I look at the last 2 terms, it looks like here, well, we want to pull out a negative. Remember, if this starts with a negative, we want to pull out a negative. And I'm going to pull out a negative 4. Okay, and that's also going to leave me with 5x and then minus 2. Okay, so we know we're on the right track because these match up. So let me first group together what's on the outside of the common parentheses. So I'm going to group together my x squared minus 4 as my first factor. And I'm going to rewrite the 5x minus 2 just once. Now, if we look here, right, don't we have a difference of perfect squares? All right, so we could factor that further to x plus 2 and x minus 2. And then we're just going to take the 5x minus 2 and bring that right down. All right, so that's a pretty quick one. So that's it. That is fully factored. Okay, number 23. So Mrs. Paris created a quartic. A quartic is a 4th degree. Okay, x to the 4th. Polynomial function f of x with a leading coefficient of negative 2. Okay, so it has a negative leading coefficient. So we know that our graph is going to, on the right, end up pointing down. The zeros are, okay, so they give us the zeros. Now, some of you think we're supposed to switch the signs here. We are not supposed to switch the signs. If they give you the zeros or the roots or the solutions, that's telling us where the graph crosses the x-axis. Okay, so I wanted to just kind of put that there so everyone sees the zeros, which is what they give us here, tell us where the graph intersects the x-axis. Okay, so we're going to intersect the x-axis at positive 2. Let me draw this out. So let me just do this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 in the negative direction. Okay, so it intersects the x-axis at 2 and 5, so positive 2 and positive 5, and also at negative 1 and negative 3, so negative 1 and negative 3. Now, I did make a note here because this is what I want you to keep in mind. It's the factors that have the opposite signs. Okay, so we'll get to that in a minute. Now, if we were to sketch this, just keep in mind, if the leading coefficient is negative, it means our graph has to end off coming down. So, like, if it's easier for you to start from this side, your graph is going to, if it has to end off coming down from the right to the left, it's going to look like this. It's going to go up, down, like that. Okay, that's again from the right, going from the right to left. Usually we graph from the left to the right. So if we were graphing from the left to the right, it would go up, down, up, down. And I'm going to put arrows, and I'm going to label that f of x. Okay, and I know that there's no multiplicity. It's not going to be bouncing off at any of these x values because it's a quartic, which means a fourth degree function, and it has 4 zeros. Okay, now, it's the factors that have the opposite sign. Now, when it says write an equation for f of x, I would write it in factored form, and I would leave it at that. Okay, so we're going to write f of x equals. Now, first of all, the leading coefficient is negative 2. So let's put negative 2 there. And I'm going to go right in order of how they gave us a 0. So if we have a 0 at positive 2, the factor is going to be x minus 2. If we have a 0 at positive 5, the factor is going to be x minus 5. If we have a 0 at x equals negative 1, the factor is going to be x plus 1. And finally, a 0 at x equals negative 3 corresponds with a factor of x plus 3. Okay, they do not say to write it in standard form, so I would not multiply all that out. That's just leaving, there's room for error there. If you leave it at this, this is full credit, so I would definitely leave my equation just like that. Okay, so number 24 says determine the solutions algebraically. Okay, so the first thing we want to do when we have a radical equation is we want to get this radical all by itself. So on one side of the equation. So let's first get rid of this positive 3a. All right, so we're going to do that by subtracting it from both sides of the equation. And I'll line it up underneath the 7a. All right, so these cancel off, and we can bring down the radical. I'm going to bring it over here to give myself a little more room. So I could bring down the radical 11a squared minus 21a plus 7. Okay, and then on the right side of the equation, I'm just going to combine my like terms. So 7a minus 3a is 4a, and we're going to bring down that minus 1. Now, the reason we get the radical by itself is because in order to get rid of a radical, right, in order to get rid of the square root, we just square it. So now that it's by itself, what we're going to do is we're going to square both sides of the equation. You don't have to put this side in parentheses, but if you want to, you can. This side we do because we want to square this entire side of the equation. All right, so on the left, a square and a square root cancel each other out. So we could bring down what's underneath the radical. And then on the right-hand side of the equation, if we have a binomial squared, it just means there's 2 of them, so we're going to write it out twice. Okay, I want to emphasize, please do not try to just distribute the square inside the parentheses. Okay, that's not what this means. It means we have 2 4a minus 1s. And what we're going to do with that is we're going to double distribute. So I'm going to, 4a times 4a is 16a squared. 4a times negative 1 is negative 4a. Negative 1 times 4a is negative 4a. And negative 1 times negative 1 is positive 1. Okay, and then on the left-hand side of the equation, we're just going to bring this down. Now, in addition to combining like terms, we also need to get everything to one side of the equation. And since this a squared term has a bigger coefficient in front of it than this a squared term, I'm going to bring everything to the right because I'm going to have a positive leading coefficient. So I'm going to subtract 11a squared from both sides. I'm going to line that up underneath my a squared term. I'm going to add 21a to both sides, which I'm going to line up underneath these two a terms right here. And then I'm going to subtract 7, which I'm going to line up right underneath my number. Okay, so on the left side of the equation, we can see everything just cancels. And if you don't like to have 0 equals in front of the equation, you could always put like the equal 0 over here at the end. That's up to you. All right, so now let's combine our like terms. 16a squared minus 11a squared is 5a squared. And then we have to combine all 3 of these a's. So negative 4a, and positive 21a. So negative 8a plus 21a would be positive 13a. And then finally at the end here, the 1 minus 7 is just negative 6. And, I mean, you could use a quadratic form if you want, but I'm just going to factor. So there's nothing that we could factor out of all 3 of these terms, but because our leading coefficient is something other than a 1, we know we need to do the rainbow. Right, so we're going to multiply these out. So we need to come up with 2 numbers that multiply. I'm going to do it in a different color, to negative 30. Okay, so we're going to multiply to negative 30 and add to positive 13. All right, so what do we got? Positive 15 and negative 2. All right, so let me bring down my 0 equals. And remember, I bring down the first term, and I bring down the last term. And those 2 numbers that I just came up with, right, the positive 15 and the negative 2, we're going to put right in the middle. But don't forget, since this has an a on it, we need to attach a's to these. Okay, every step of the equation has to be equivalent to the step above it. So like if we were to combine these, wouldn't these combine to give us the previous step? Okay, so that's why whatever's on this middle term is what we put on these 2 terms. All right, so now we can just jump right into grouping. All right, so we have 0 equals. Out of the first 2 terms, we could pull out a 5a, which is going to leave us with a plus 3. Okay, now out of the next 2 terms, since it starts with a negative, we know we're taking out a negative, and we could pull out a 2, which is also going to leave us with an a plus 3. All right, so we have 0 equals, and we're going to group together what's in front of our parentheses, so the 5a minus 2. And then we're going to bring down that a plus 3, but just once. And at this point, we can make our t-chart and solve. Okay, so we know we wind up with, over here on the left, a equals the opposite of what's here, so positive 2 over what's in front of the a, 5. So a equals positive 2/5. And if you prefer to write that as a decimal, like 0.4, you can do that. That's up to you. Okay, and then over here, we wind up with a equals negative 3. Now, with radical equations, it's super important to check. Sometimes you solve everything right, but you may wind up with an extraneous root, something that does not check out in the original equation. Okay, and I am okay with you using your calculator to check, so I'm going to show you how we do that. Okay, so what I did was I had to use, I mean, I could have used a, but it's just easier to use an x in your calculator. So I took 2/5 and stored it as x and hit enter. Then what I did was I went back to the original equation. Please don't go back to one of these middle steps. You go back to the original equation. You type in the left-hand side of the equation. Okay, that's what I did here. And it gave me 9/5 as an answer. Then I typed in the right-hand side of the equation. And if it gives me the same answer, which you see it does, see how they both say 9/5? That means this answer of 2/5 checks. So I'm going to just circle that. Okay, this one checks out. Okay, now let's do the same thing, but we're going to store x as negative 3 this time. Okay, so this time I stored x as negative 3. And when I typed in the left-hand side of the equation right here, the output value was 4. But then when I typed in the right-hand side of the equation, look at that, the output value was not 4. It was something different. It was negative 22. So because the left side and the right side of the equation don't match, we could say that negative 3 does not work. It's an extraneous root. Okay, and there you have it. I'm always a fan of writing out extraneous root. It shows you really understand it. But even if you cross it off, that will still be full credit. Okay, so number 25, we want to solve the system algebraically. Now, the first thing you want to do is you want to get either x or y by itself in one of these 2 equations. Personally, I think the y in the second equation is the easiest variable to get by itself because there's no number in front of it. So in order to do that, let's just add 2x to both sides of the equation. Okay, so that leaves me with y equals, and I'm going to just write that as 2x minus 8. All right, now since y is equal to 2x minus 8, can't we take that 2x minus 8 and substitute it in for y into the other equation? Okay, so see what this y is? Instead of writing y, we're going to write 2x minus 8. Okay, so what I did was I brought down the x minus 1 squared, the plus sign. I replaced this y with a 2x minus 8, and don't forget about that plus 4 in there as well. And then I just put everything else down. All right, now, I know that if something is squared, we have two of them, right? So we could write x minus 1 times x minus 1. But before we do that here, if we wrote this out twice, we'd have to triple distribute. That's kind of a lot of work. Why don't we first combine our like terms? Isn't negative 8 plus 4 just negative 4? So let's rewrite this parenthesis as 2x minus 4. Okay, and now since we have squares on these parentheses, that means that there's two of them. Okay, so we're going to have to write them out twice and double distribute. All right, so let's double distribute this out. All right, so we have x squared minus x plus 1. Okay, then let me bring down this plus sign, and we'll double distribute the next set of parentheses. So 4x squared minus 8x plus 16. And then let me just bring down the equals 40. Now, we could see here we do have a lot of like terms to, combine. But while I do that, I'm also going to get this side of the equation set equal to 0. So let me just subtract 40 from both sides of the equation. Okay, so we have equals 0 on the right. Okay, on the left we have, let's see, x squared plus 4x squared would be 5x squared. And then negative x, negative 8x, and negative 8x would be negative 18x. And then what numbers do we have? We have 1 plus 16 minus 40. Okay, so 1 plus 16 would be 17, and 17 minus 40 is negative 23. Okay, so from this point, it's a quadratic. You could use a quadratic formula, or you can factor. All right, I'm going to do factoring. So because the number in front of the x squared is something other than 1, we need to bring down the first term, bring down our last term, and come up with two numbers that multiply to 5 times negative 23, which would be negative 115. So I'm going to multiply to negative 115 and add to negative 18. So positive 5 and negative 23. There you go, the two numbers we were using, right? So positive 5, and don't forget the x on that, and negative 23. And don't forget the x on that either. All right, so let's get into grouping. So I'm going to group together the first two terms, and we can pull out a 5x, which leaves us with x plus 1. And out of the next two terms, we could pull out a negative 23, which leaves us with positive x and positive 1. Okay, so we're going to take what's in front of the common parenthesis and group that as our first factor. So 5x minus 23. And then we're going to rewrite the x plus 1 once as our other factor. All right, so when let me get myself some more room. So when we solve, we wind up with x equals positive of what's here over what's in front of the x. So positive 23 over 5. And over here, we wind up with x equals negative 1. All right, I'm just going to, that 3 is a little funky. I'm going to just rewrite that. So 23 over 5. All right, now keep in mind, these are just the x values, right? If we look back at our original equations, don't they have x's and y's? So we need to figure out what y values correspond with those x values. Now I'm going to use this equation because this equation already has y by itself. So y equals 2x minus 8. So y equals 2x, but in place of the x, we're going to plug, in this case, 23/5. And then remember, it was minus 8 at the end. Okay, so we need to figure out what that's equal to. Okay, when you do, you end up getting y equals positive 6/5. Okay, and then over here, we would do y equals 2. And in place of x, we're putting a -1 this time, minus 8. Okay, so that would be y equals, and this is equal to -10. Now, the only thing we have to do is we have to write our answers as coordinates. Okay, I'm going to do that off to the side here. So, the first coordinate, remember, goes x, comma, y. So the first coordinate would be 23/5, that's our x value, comma, 6/5, right? That's our y value. And then our other coordinate would be right here, -1, -10. Okay, and if you wanted to check, you could substitute in either one of these 2 points. Actually, you should do both of them, but one at a time. Back into our original equations, right, up here, and each coordinate to check out in both of the 2 equations. All right, number 26. So Brody will be 22 when he graduates from college. Brody's parents told him that when he graduates college, they will give him $20,000 to put into a retirement fund. He has 2 financial planners assuring him that they have the best plan. All right, so let's start. Mr. Smith's plan will earn him 4.5% interest compounded monthly. Ms. Harris's plan will earn him 3.94% interest compounded continuously. Okay, so it looks like in this first part, they want us to write 2 functions, one for S of t, and then one for H of t for Harris. Okay, so let's start with S of t. So S of t is going to be equal to, now, because it says compounded monthly, we need to use our compound interest formula. Okay, so here it is. So in place of the A, we wrote S of t. P is the initial amount, which is $20,000. So let's plug that in. Okay, this is supposed to be a comma. All right, and then we have 1 plus the rate. So 1 plus, now remember with the rate, since there's a percent, we want to take the decimal and move it back twice. So 1, 2. So that's going to be 0.0405. We want to put that over n, which is the number of compounds per year. So if something's compounded monthly, it means it's compounded 12 times per year. So I'm going to replace this n with a 12 as well as the one over here, and we want to leave it in terms of t. Okay, they say t years, so you want to leave that t there and here as well. Okay, now Ms. Harris's plan will earn him 3.94% interest compounded continuously. Okay, remember when we see the word continuously, we're going to use our A-part formula. So in place of the A, we have H of t, and then we can write equals. In place of the P, it's still going to be 20,000, and E is just an E. In place of the R, well, if we have 3.94% to get it out of percent form, we move the decimal 2 places to the left, so that'll become 0.0394, and then let's leave it in terms of t. All right. So Brody wants to retire when he is 55. Which plan will maximize his account and by how much? All right, now let's think about this. Brody was 22 years old when his parents started the account. So if he wants to retire when he is 55, well, wouldn't that be, let's see, 55 minus the age which he started it? Wouldn't that be 33 years later? So what we want to do is we want to find the value of the account after 33 years for both of these and figure out which one is, bigger, which one will accumulate him more money and by how much. Okay, so what I did was I replaced this T with a 33 as well as this T with a 33. Okay, and I'm going to plug that in my calculator and I'm going to see what I get. And then I did the same thing with Harris's plan. I replaced both T's with 33s. Okay, so now we're going to plug these in our calculator and keep in mind it's money. So with money, you want to round to the nearest cent. All right, so this is what we get in each of the accounts. So we could see that Smith's plan is going to make him more money. Now we want to know how much more, so let's subtract those. And when we do, we wind up getting $2,542.31. Okay, so you could just write it out in words. Mr. Smith's plan will maximize his account by $2,542.31. Okay, so now right here I just wrote Harris's plan, the one we had above, because we want to figure out how long, right? So we're looking for the T. Will it take for Mr. Harris's plan to double Brody's investment? Now think about it. If Brody invested $20,000, if you doubled that, wouldn't that give you $40,000? So we're going to replace this side of the equation. Let me erase that with $40,000. Okay, and then this is what we're going to solve. So we know we first have to divide by the number in front of the E. So let's first divide both sides of the equation by 20,000. So that'll leave us with 2 equals E to the 0.0394 T power. Okay, to get rid of an E, we put an ln in front of it. If we put an ln in front of one side of the equation, we have to do the same to the other. Now on the right side of the equation, an ln of E to any power leaves you with just whatever the power is. So these kind of cancel each other out, right? And we could just bring down the exponent. So now it is no longer an exponent. Okay? And we'll bring down the ln of 2. Now to finish, we want to get this T right here by itself, so we need to get rid of the number in front of it. So let's just divide both sides of the equation by that number. Okay, and when we do, that's going to leave us with, you could just plug this right in the calculator, to the nearest tenth, 17.6. Okay, so don't forget your units. You always need units with word problems, right? So the units here would be years. Okay, and finally the last part. So now this one deals with Mr. Smith's plan. So I rewrote Mr. Smith's plan from the front of the page, and they want to know how long will it take to triple Brody's investment. So if he invested $20,000, right, if you triple that, wouldn't that be $60,000? So we're looking to replace the left side of the equation with $60,000. Okay, so let's solve it. So again, to solve this, we start off the same way we did the last one. We're going to divide both sides of the equation by 20,000. So that'll leave us with 3 equals, I'm going to just leave the parentheses as is, 0.0405 over 12, and that's to the 12t power. Now, since we're solving for an exponent and there's no e involved, we know we're going to need to use log. So let's put log in front of both sides of the equation. And that's going to bring our 12t right to the front. So it leaves us with log of 3 equals 12t times log of what's in the parentheses. Okay, so we're trying to get the t all by itself. Okay, so we need to get rid of this as well as the 12. Now, I like to get rid of this first, although it really doesn't matter. So to get rid of it, we're going to divide both sides of the equation by log of what we have in the parentheses. All right, so on the right side of the equation, those are going to cancel, and we could bring down the 12t. And this you're going to plug in your calculator. Now, on my paper, I'm going to round it to 4 decimal places, but I want to leave that entire number in my calculator because I'm not done yet. I still need to use it. What we need to do is to get the t by itself, we need to, in our calculator, just hit divided by 12. We want to divide that value right here by 12. And when we do, I'm going to come over here to the nearest tenth as well. You wind up getting 27.2, and your units are going to be years.